Everyone. For my Unit 6 discussion, I'm explaining rotational motion by comparing two opposite ends of the structural spectrum, the massive 400-foot icon part wheel in Orlando, and the microscopic ATP synthase motor spinning continuously inside our own human cells and plant cells to produce energy. Mathematical physics and my diagram. Let's look at the mathematics of their rotation using our fundamental formulas, angular momentum, and rotational kinetic energy. On the left, the icon part wheel has an enormous mass in a 61-meter radius, giving it a massive moment of inertia. Because inertia is so large, it holds immense angular momentum and rotational kinetic energy, even though it spins at a tiny angular velocity of just 0.005 radians per second. On the right, the cellular ATP synthase, found in both human and plant cells as a universal enzyme, the fundamental energy currency of life, has a molecular mass and radius near zero, making its moment of inertia negligible. To achieve enough rotational kinetic energy to synthesize ATP, the cell compensates by maximizing its angular velocity, spinning at a staggering 9,000 RPM in rotational frequency. The microscopic ATP synthase motors inside human and plant cells spin roughly 180,000 times faster than the icon part wheel. In rotations per second, the cellular motor spins 150 times every second. The icon part wheel takes 1,200 seconds, 20 minutes, just to spin once. Our cells are incredible, or cells are incredible in general. System dynamics and conservation. How do these systems change? Both possess a fixed shape, so their individual distribution of mass stays constant during operation. Their changes in rotational speed are given entirely by external torques. Because external torques are acting on these systems, angular momentum is not conserved within them, but rather changes over time. For the amusement ride, electrical grid tires apply an external torque to change its angular momentum. For the cell, a gradient of proton flux generates an electrostatic torque that drives the nanomotor. While angular momentum changes due to these external forces, total energy is perfectly conserved as electrical or chemical potential energy, converting directly into mechanical rotational kinetic energy. In conclusion, ultimately, whether dealing with millions of pounds of structural steel or a single biological cell, the laws of rotational kinetic energy and angular momentum govern our universe identically across all scales. Thanks for watching.